Okay, so we've got a bunch of questions here dealing with linear equations, and our goal is to match these graphs to these equations. What I'm going to do is I'm going to start actually with the number 15 right here, because what they tell us is that the y-intercept is equal to 1, and the slope is equal to 1/2. So what does that mean? Well, the y-intercept, remember, all that refers to is the point at which your line intercepts or crosses the y-axis, right? So if we look at example C and example B, right? Take a look there. We have our y-axis. Let me choose the right color here. Choose blue for the y-axis. And in each case, the pink line crosses the blue line, right? And the blue line is the y-axis, and the pink line is the function we're trying to match to our equation. Now, when they cross, you can tell when they cross just by counting up or down on the y-axis. So here, literally, I'm going to just look over, highlight the point that they meet, and I realize that for both of these, the y-intercept is 0, 1. The point at which they meet is 0, 1. And you would say the y-intercept is just 1, because it's the value of the y-axis when the line crosses it. You don't need to say the point 0, 1, because when you say y-intercept, it's implied that the first value is 0, right? Because if you're on the y-axis, that means you're just on the y-axis and haven't moved at all on the x-axis, right? 0 here is at the x-axis. If I move left or right, the x value is no longer 0. But on the y-axis, all of the x points of all the coordinates are 0. So which of these two lines represents this function right here? Well, if the slope is 1/2, right, remember slope is just a rate or a ratio. It's saying that the change in the line is 1 over 2. And that means 1 refers to the change in the y, or delta y, or the rise, you might have heard it spoken of that way, and 2 refers to delta x, or the run. That's the change in the height over the change in the left or right direction, vertical change over horizontal change, rise over run. So this tells you that on this line, if it's correct, when I go up once and I go over right twice, that's a slope of 1/2. If I go up once and over twice, that's a slope of 1/2, right? So it's up 1 over 2, up 1 over 2. Or we can reverse that. We can go left 2 and down 1, left 2 and down 1. Or you can think of it like this. It's probably more appropriate to think of it as down 1, left 2, down 1, left 2. Right? The reverse of what we first thought of it as, which was just, let me clear this off. Right, we first thought of it as up over to the right, up over to the right. We could reverse that, down, left, right? Thinking of the slope in either way is the same. So here graph B is our match for number 15, right? The slope is 1/2 and the y-intercept is 1. Remember our y equals mx plus b format. That's our slope-intercept form, where the m represents your slope. So we could say y equals 1/2, that's for m, x plus, right, plus 1, because b represents your y-intercept, and here the y-intercept is 1. So that's the equation for this line. Now c doesn't match. If we look at the slope of c, right, here if I go up or down, I try to find an even point where it works. If I go up, right, I have to go up 3 and over once just to reach the next point that's on an integer. Here that's 1, 4, right? I could have gone any other distance to figure out the slope, but why make it difficult on myself here? I'm going to go from one point that has 2 integers to another. So here I go from 0, 1 to 1, 4, and that the delta y, the rise, is 3, and delta x is 1. So here the slope is not 1/2, it's what? Well, it's delta y 3 over 1. So now let's look at this next example, where m equals 3 over 1, or just 3. Which one of these three choices could it be? Well, it must be number 12, but we'll talk a little bit more in detail about it because you won't always have multiple choice at your disposal. It must be that one because, again, if we follow the y equals mx plus b format, that means the number next to the x is the slope, right, the coefficient there. Here, we have 3x, right? So 3x tells us, oh, for this line, the slope is 3, and we know we have a slope of 3. And then plus 1. And that makes sense because the y-intercept is also at 1, so this is our choice. So those match up. So now A and D must represent not 12 and not 15, assuming we don't repeat anything here, but 13 and 14. So this is nice and easy now because, well, we're dealing with multiple choice, but let's think about it critically as if there wasn't multiple choice, right? So on D, right, our y-intercept is what? Well, it's the point 0, negative 3, so it's just negative 3 is our y-intercept. So we want an equation in y equals mx plus b format where we're adding negative 3 or subtracting 3 to represent the y-intercept of negative 3. So this is our answer right here, number 14, right? And y is equal to x minus 3, and we're done basically. We know 13 has to match the first one, but we're here to understand, not just to memorize, right? So let me just move this equation over. Okay, so this is y equals x minus 3. So if you see that, if it's just y equals x minus 3, the coefficient on x is just 1. So this means for this case, the slope is 1. And that means I can go up 1 over 1, up 1 over 1, up 1 over 1. That's the rate of change of this line. I can also go down 1, left 1, down 1, left 1. And I can also do other combinations, right? As long as I go up and over the same amount. So if I went up 3 and over 3, right, that's still really 1. 3 over 3 is 1, and it fits the line. So clearly, I mean, in this case, 14 definitely represents graph D. There's no ambiguity about it, but I think it's important to understand the slope and intercept. Same thing with this one. So y equals negative 2x plus 2. Let's talk about this match right here. Well, you see a plus 2. That means your y-intercept has to be at 2, and it is here, right? This point is what? Well, it's 0, 2. So that matches. And the slope is negative. Now, some people will rush and say, okay, that means the slope goes down. But remember that lines, if you look at them, they're going in two directions. So what would it really mean to say down? That's not really accurate. You want to always think about what slope is. Slope represents the change in two variables at the same time, y and x, right? So when you describe slope, don't say up or down. Talk about how the two variables are changing with respect to each other. In every case so far, we had a positive slope, and in every single case, what happened? If I went up in my y, I also went to the right on my x. And if I went down on my y, I also went left on the x. That's called a positive slope, right? It's positive because if y is increasing, so is x. But if y is decreasing, from going down in height, my x value is also decreasing or going to the left, right? They're directly related. Here they're inversely related. It's a negative slope or an inverse relationship. What's going to happen? Well, if I start here, let's say, and my slope is negative 2, in this case now we have a new problem, right? M is equal to negative 2, let's say, over 1. You could also think of it as 2 over negative 1. You can put the negative sign wherever you want. And we'll talk about why that makes sense here, even on that picture, but mathematically, right, negative 2 divided by 1. This first case, that's negative 2. And 2 divided by negative 1 is also negative 2. So you can really, put that negative sign wherever you like. Anyway, so let's see what negative 2 over 1 is the slope. What does that mean? Well, for me, it's the rise over the run, so negative 2, I go down 2. And then, since I'm decreasing on my y, my x doesn't also decrease, it increases, right? If it was a positive correlation or positive slope, they would both decrease or both increase. Here, whatever one is doing, the other is doing the opposite. So if y is decreasing, x is increasing. If x is increasing, y is decreasing. They're reversed. And I can keep going here, down 2 over 1, down 2 over 1. But we can also look at it this way, right, where y is positive. So if y is positive, we go up 2. But since we're going up in the y, we decrease in value in the x. We go over to the left 1, and it works. If I started here, I go up 2 over 1, up 2 over 1, up 2 over 1. It still works, right? So the slope here, if it's negative, don't just think of it as up or down. If it's positive, don't just think of it as up or down. Think how y and x change in the same direction if it's a positive slope, and in inverse directions if it's a negative slope, and that really will take you a much further way into mathematics than just saying up or down. All right, thanks.